We are going to do chapter 5 this time. It's all about branches, or the book calls it branches. I will refer to it as conditional statements because a condition has to be met before something happens. That's old terminology for you. I am old, so that's, pretty normal. Making sure the speakers are working. All right. So we're going to do a PowerPoint. To introduce it, do a couple of examples during my PowerPoint. On Thursday, I'm going to bring in a lab for one of the previous times I've taught it and do it in idle with you as a demonstration where you see what it looks like outside of the Zybooks environment, because I think that might be more helpful to some of you guys. We are also got a discussion post due this week, so read it, be aware it's there, don't forget about it. I can't believe how many people are taking zeros on the discussion posts when they're pretty much free grades, because as long as you answered the question, whether I agree with you or not, I give you credit for it because it's a discussion. We've only had 2. This will be the 3rd one. 3rd one this week. And now that you said that, I may have called it discussion 2 again, and I need to go check that because now you got me second guessing myself. I don't know. I'm bad about putting the wrong night. Oh, okay. This says technical interviews. So we're talking about technical interviews this time. Everybody's probably been to a job interview of some sort by this point in their lives. I would hope you've had a part-time job somewhere. May not. Some of you may have been lucky and never had to work. But anyway, technical interviews are different than regular interviews, or it's different if you're going to Walmart to interview for a job stocking shelves than if you're going to Amazon and interviewing for a programming job. So technical interviews usually put you on the spot. They usually take a long time. If they're really interested in you, you could be interviewing all day long. So what they do often, and I know the job I had you guys look at probably was an introduction kind of job, but for even intro jobs, they often will put you on the spot and they will ask you to solve programming questions. Not necessarily on a computer, but with a whiteboard or something. And it's not so much, sometimes they want to see if you can actually code your way out of the mess they gave you. But a lot of times they want to see how your brain works, how you deconstruct the problem, what your thought pattern is, what your attack is going to be, to make sure that you know a logical thinking skills, or that you know what you said on your resume, you're talking the right talk and you're doing the right actions. Some examples that you might see, how do you reverse a string in Python? That's pretty simple stuff. And they may just have you talk it out. Tell me in your own words the steps you would go to reverse a string in Python. Tell me in your own words. I've actually been to some where they hand me a marker and say, there's a whiteboard over there. Show me how you would do this in XYZ language, whatever language it is. So I have you discussing that, whether or not you've ever had one before, what you think are good things you can do to prepare for it. And we'll talk a little bit more about this as we go through, because the ultimate goal, I assume, for all of you is that you're going to get a degree and then you're going to get a job and you're going to be gainfully employed and your life's going to be better when you're in the real world. So that's what it is. I don't want a 3-page paper here. I want 1 to 2 paragraphs. So, I just want you thinking about it. Unless you just want me to assign papers.
Nope.
So that's the discussion post. We'll jump back to the PowerPoint now. But we are going to talk about making decisions using if statements. My PowerPoint is kind of a summary of what the chapter is. So the chapter is going to have some much greater details than what I'm covering today, which is good. What it's there for, is to get a supplement to what I do in class. But if I miss something, or you say, oh, she didn't cover that, it doesn't mean that it's not important. It just means that I'm trying to hit the big ideas. Hence the reason you have to do all of the other stuff. So we've done some control structures. We've been talking about control structures. We haven't called them that, but we have been doing it because we've been using functions, right? We've been using functions on our strings. We've been using the print function. That's a type of control inside of our program. If statements are conditional controls. They happen when a condition is met. And it's how we can group things, or we can make a decision one way or the other on how our program is going to proceed based on those conditions. There's another one that we're going to do next called loops, and that lets us repeat things as a control. It goes until. So these are really bad examples of my slides. I know they need updating. I'm so sorry. I just haven't felt like doing it yet. So an example of making a choice, and yes, I know it's a bad one. Stop shaking your head at me. You're shaking your head at me. Disappointed. All right. So let's just say you're going to go buy the next great iPhone. Well, you need money for that, right? I don't even know how much they cost nowadays because I don't buy iPhones. So you need at least $1,000 or more to even consider an iPhone at this point. Or you could get the Microsoft Lumia 735 for free. It was a piece of junk. No, I used to work for Microsoft, and I will tell you that none of us would recommend you use a Microsoft phone. I'm not even sure they make them anymore. I think they got out of the phone business. I'm not positive. So if you have more than $1,000, you can go buy an iPhone. If you're broke, then you're going to get the free phone, right? Whatever that may be. If you're like my dad and you're technologically challenged, you're going to get the flip phone because that's all. So it's an if statement. If this is true, I can do this path. If otherwise, I have to go down the other path. It's like a fork in the road. You got to decide if you're going right or left. So this would look what it would look like in idle or in your Zybooks window. If money available, the variable money available, is greater than 1,000, I'm going to do the steps. If that is true, I'm going to do the steps that are indented under my if. This is where indentations start coming in. Remember, I told you early on that spacing is very important in Python. This is why these indents group lines of code together. Also, another syntax thing that you need to pay attention to is a colon at the end of this line. And that's going to be something that you forget a lot to begin with. And if you are Java trained, you're going to want to make it a semicolon because Java uses semicolons, not colons, at the end of lines. Of course, in an if statement, you'd use brackets. So, yeah. Anyway, you notice also if you've done other programming languages that the condition is not in parentheses. Python doesn't make you do that. Other programming languages do. If you do put the parentheses in, though, it won't save it. So you'll be good. So you have an if statement. It starts off with the keyword if. If you put it into idle, it comes up a different color. Because it's a keyword. If that is true, you do the indented line. Else, you do the line indented under the term else. So if you only have one condition you're testing for, you have if and an else. You can have an if statement without an else. So if it's not true, there's not another option. You could just leave that off. Yeah.
Question. So the else, or if something else is used, the indentation determine what to execute.
Yes. So everything, if there was multiple lines that needed to go with the if, they would all be indented together. So they replace the curly braces. So this one has a test, and it has two options. If it passes the test, I go one direction. If it fails the test, I go another direction. And then I can print out whatever phone I get. Now, I'm going to tell you, if you are using my PowerPoint and you want to copy and paste these examples into IDLE, it doesn't work. And I'm going to tell you why. The indentations are wrong, and the quotation marks are not the right quotation marks. So if you're ever copying code, you have to retype the quotation marks. It's a formatting thing with Microsoft, because their quotation marks are cute and slanty. And anyway, huh? Cute and slanty, yes. So that's one example. But you also can have a whole bunch of choices. So like we're sorting out whether or not your average grade is an A, B, C, D, or an F. Well, that's a bunch of conditions I have to meet, right? So I have an if, and then what we call an else if, and an else if, and an else if, and then finally we get to an else, right? So if it's greater than or equal to 90, I'm going to call it an A. If it's 80 or above, I'm going to call it a B. 70 above is a C, so on and so forth. But it matters what order you do this test in. Because if I did it in the wrong order, like what if I started with F first, then you need boundaries on both sides, right? So you would need a test that's like, if it's 0 to 59, that's an F. If it's 60 to 69, that's a D. But if you do it in the right order and you start with A, because it never gets to the test below it. Once it finds the test that's true, it ignores the rest of the test. Does that make sense? So in code, it would look something like this. And I actually have IDLE pulled up over here. So if I took this and I said, oh, I want to see what that looks like. So I'm just going to copy and paste it. Copy. And I go over to my IDLE window and I paste it. It looks like this. This is not going to work for IDLE. IDLE is going to go, you got some bad problems here. If I run it, I'm going to get error messages, unexpected indents, right? So I would have to clean all this up. So I would go back and I would take all this out. And quite honestly, I would take this back and just indent it all. But it's may or may not be faster than retyping it. So now the indents are right. I run, and now it's going to tell me that I have an invalid character because it doesn't like my quotes. So I have to fix all of them. Don't ask me why the first line went in correctly and the rest of them didn't. But so those quotes were fine. These are not. Funky. Because in the encoding, those slightly slanted ones have a different encoding number than the non-slanted ones. But IDLE only recognizes the standard ones.
Universal.
Grade is not defined. Oh,
Oh, yeah.
I forgot to ask them for grade.
Be realistic.
There you go. Now grade's defined. So now it should ask me. Oh my goodness. Hey, look, even me, I can't program today. It's being realistic though, right? So I can enter a grade. I can go 85. Once your num key's on, and hit enter, and it tells me B. Right? Does it giving you examples and idle help?
Yes.
Okay, just checking. So I'm gonna try to continue to do that, and we're gonna use the book more supplemental and more examples from me. So this is an example of a multi-condition if else if statement. Now notice, it doesn't say else if on the second test. It says ELIF. And it says that because for some reason, oops. You guys in the back now probably can see the code better. It says that because for some reason in Python, they were too lazy to type else if. So they shortened it and abbreviated it to ELIF. ELIF. 2 characters, whatever.
If you have syntax problems on the rest of the LF, it stops at D. Because it doesn't stop there until.
The syntax, if there is a syntax error, it will never run. It's going to tell you that before any part of it runs. If it's a straight up, you mistyped a syntax.
I'm only asking seriously, I'm not pointing it out, but the semicolon, that's supposed to be there, or that's on the letter grade, no?
Well, that semicolon's there.
Didn't.
It's not supposed to be there. But obviously it wasn't a problem for the code.
Just curious how simple it is.
And John is.
Python, and you can quote me on this because it's the funniest thing I've said in decades, is a loosey-goosey coding process, if you ask me.
Comparatively speaking, most of it.
Because it fixes too much and it's too forgiving compared to other programming languages. If I had done something like that and had just a random keystroke in a Java file, it would not have run. So that good catch on your part, and it's probably because I copied and pasted that original example from
I
somewhere
didn't know
else.
if that meant that it stopped where it stopped, after
No.
executed, the rest of it can be
No.
whatever.
It was just a typo on my part. So good catch on that one. Is it in my slide that way?
Yep.
Well, let me fix that. Of course, that probably won't fix it on for you guys. Anyway, but we'll worry about it. I'll go fix it and re-upload it. So back to where we were in the slide deck. So we did that. So you can have conditions that have multiple sections. You also can do the else if and set it up where it's only partial ranges. You just have to be careful when you do it that you have your greater than and less than right. Some of the common errors and mistakes in a conditional statement is that you put less than in, but you meant greater than, or you put less than and equal to in, and you didn't really need the equal to, or you left the equal to out. So those are pretty common mistakes. It's also really common to do if instead of if else if. So let's talk a little bit about that as we will talk about that as we go on, but that's a mistake. You should not have ifs following each other if they're all tied to the same decision tree. So you're always going to have the word if, whatever the condition is, and then the colon as your syntax pattern. And then whatever statements are to be executed are just indented under the test. You can have one line there, you could have a dozen lines there. As long as they're indented properly, they will stay with the right test. If you unindent something, they no longer belong to that and they just run as extra code. But you're also probably going to get an error at that point because if you have an else or an else if further down, it's not going to have an if that it matches up to. You can have an if without else's. You can't have else's without an if. These are all Boolean statements. We talked a little bit about Booleans, I think, beginning when we were talking about types. Booleans, true or false. So the condition always is going to evaluate the true or false. Now, you can actually have functions as your condition, but that function has to return a true or false value or be used in a comparison equation that ultimately gives you a true or false. So again, another really bad example because students don't study for 10 hours for the test. So if your study time is less than 10 hours, you need to go study some more, right? There's no else here because there's no other option for you. You just need to go study more if you haven't studied for 10 hours. After you get through this, you get to go take the test. And somebody's like, well, why isn't there an else there? Because you got to take the test one way or the other. The if statement is just telling you what you should do before you get to that line. Now, if you didn't study and you tied it into an else, didn't study, go study more, else take test, then the person that didn't study never gets the option to take the test the way that code's written. Does that make sense?
What does that return? Nothing?
Returns nothing right now because it's not in a function. We haven't actually talked about functions yet. So in theory, take test is another function all in and of itself that would take you over to open up your online exam. Yay. Bad function. So, like I said, the syntax is always if and a condition, then it has else. You can throw some else ifs in there. But the statement and the condition, if you have one, must be true or false. If you use the word else, there's no test because it covers everything that doesn't fall into the previous test. If you need to test again before you use whatever, then you need an else if. And it makes more sense once you've done it a few times. We're going to do some examples. You'll see what I'm talking about. So again, studying time. I'm trying to get a point across that y'all, that you or your peers need to study more. Maybe not you. I have no idea what Snapchat is. I'm going to show my age. Never used it. If you have not studied 10 hours, if you've studied less than 10 hours, you need to go do some more studying and you need to read your textbook. Else, you can go play on Snapchat. Then you go to bed. But everybody's going to bed eventually, right? But not everybody's getting to play Snapchat. I know. I know you don't really play Snapchat, but you can't go get on Snapchat and send messages to your friends unless you have 10 or more hours of studying. That makes sense. So these, you get one or the other, but you don't get both the way this code's written. But everybody goes to bed eventually. At least I hope you sleep sometimes. So if you have an if else, it looks like this. You have condition, you have your first condition, your second condition, and your third condition. Remember, the else statement does not have a condition because it should catch everything not covered in the others. By definition, the else is everything left over. You cannot have an else condition if you want to ignore everything left over. It doesn't fit in one of your tests, you don't want to do anything with it, just leave the else off. But you cannot have an else without the if. And usually the only time you see people trying to use an else without an if is when they've copied and pasted somebody else's code and they didn't get all the copy. So we did this already. I don't know why I have the example in there twice, but I have it in there twice. So this is again yeah. There you go. Oh, I'm sorry. All right. So this is again the letter grade thing. If we did it as a series of if statements, would it still work? We walk through this code. Is this going to work?
However, I think it would take longer to run.
All right. So give me a number. Pick a number. That would be a grade.
89.
89. If 89 is greater than or equal to 90, no, so we're skipping that one. If 89 is greater than or equal to 80, it is, we're skipping, so we're gonna do that. Letter grade is now B. If 89 is greater than 70, now letter grade is C.
Because that was.
Right, because they're independent of each other if they don't have the else in. So it does the first if statement, then it does the second if statement, then there's third if statement because they're not tied together. You need the else ifs to tie it together, or you end up with down here at the bottom where you do have an else. You say 89 is greater than or equal to 60. Absolutely is. So now letter grade D, and we don't ever get an F because it's part of the else condition. Yeah, you pass. So does that make sense? Why you have to tie them together? You'll hear them called branching trees. There's these really lovely flow diagrams in the guidebooks that I'll never ask you to write in this class, but other classes will. So look them over. They show you what happens in a graphical kind of way.
Would it be safe to say like that if continues to function down the list and if?
No, because they're all independent ifs. So this is
It continues to give you the different grade, but.
yeah, it keeps running tests.
But then LF cuts it as soon as.
Yeah, LF says, hey, as soon as I find the condition that this matches true to, I ignore everything below there because computers do anything in sequence, right? So the LFs say, I'm only looking until I find true. If I don't find true, I'm going to use the else statement and I'm going to move on. If I don't have an else statement, I'm just going to move on. So Boolean expressions are anything that evaluate to true. So if you're comparing greater than or less than, that evaluates to true or false. If you have a string, that doesn't evaluate to less than or to true or false, unless it's a variable. Now, if it's a variable, it can hold true or false because that's a type of data. You can set a variable equal to true or false, but it has to be that. There are some operators you can put things together with in Booleans. So you can have a range of things. So you could set it up where it says grade is less than 100 or greater than 89 by connecting the two comparisons with the keyword or. And then, or you can compare it with and. Does that make sense? So if I had less than 90 and greater than 89, I boxed you into one of these. By using that and, I'm telling the computer that both conditions have to be true for the next one to work. If I use an or, only one of the conditions have to be true. You're like, well, why would that be? Okay, well, if your parents, when you were a kid, said, you can go to your friend's house if you have done your homework and cleaned your room. Both those conditions have to be met, right? Or your mom might be in a generous mood and say, you can go to your friend's house if you have cleaned the kitchen or you've taken the garbage out. Well, the or statement means I have to choose one of those things to do, but I don't have to do both. Does that make sense? And then we have not. Not basically turns it into not true or not false. So we're negating the answer. If grade is not less than 60, you pass. So there's all sorts of truth tables that you can get into. The book goes into a little bit more detail, I think, on it. In the future, the truth tables are going to come back and be something important for you when you're designing architectures and things. But right now, if you're using and, if either side fails, the whole thing fails. If you're using or, only one has to be true for the whole test to be true. The only way an or is false is if both of the conditions are false. The only way an and is true is if both conditions are true. Not just changes the result. Negates it, basically. So here are some operators you can use in your comparisons. You have the double equal sign. Common mistake will be to use one equal sign and then it tries to make it an assignment instead of a comparison. The exclamation point means not. So if you need not equal to, you do exclamation point equal sign. Less than and greater than are the same as in math. Less than or equal to, you need both symbols. The less than or greater than sign comes first, then the equal to equal sign. Why does it not look like the math when we did it with the little line under it? Because there's not a key on your keyboard for that. So we had to come up with a way to indicate it. So some just examples of Boolean expressions. A is equal to 30 is not a Boolean expression. That's an assignment, right? Loop is a variable name in this case. We set it equal to true. It's now a Boolean. So you can say A is less than B. It'd be false, but it is a Boolean when it's in a comparison. Does that make sense?
But it is a what? A Boolean.
When it's comparing things,
Right.
that comparison results in a Boolean answer.
Yes.
So if I have loop, I could use loop in a condition after I've defined it as being true. And then every time that condition came up, if loop's in there by itself, it's just true and the condition runs. So if you need a loop to run infinitely, put true in there. It'll run until somebody changes your variable to false. That's actually how a lot of things, old school games ran, where they would keep telling you to do something until you press the quit key. But as soon as you press Q for quit, it resets your variable from true to false, and your loop stops running.
Simple.
The menu stops popping up. So anyway, these are some different things you can look at. If you have questions, please email me or ask me now or later or after class. Because you will use a lot of Booleans. So if we were going to write some code here in class, we could open back up idle and we could write an if statement that asks, the user how long they've studied. And if it's not of a certain amount, then we tell them to keep studying. But we've already done that in the example. So what if you wanted to put out something in ranges? We haven't really done an example of that, right? Well, we have. The ABCD is kind of in ranges. But this one's going to charge you money based on how far you've driven. So anybody's been to Florida on those toll roads, you have to pay more the longer you go. And if your car weighs, or if you're driving a truck, it will charge you more for that. So something like that. So these are a couple of tasks that are examples that you can think about. Try yourself in idle if you want to, and then send me some questions. This is my challenge to you on your own to go and think about it. And that's pretty much all I have for today. So if you want to work on those couple of challenges now and get some feedback, feel free. If you want to take off early because you got it, you don't need me, feel free. Won't hurt my feelings at all. But the participation assignment and the labs for 5 are already open. I think it's chapter 5. For branching, whatever.
The Boolean operator is type and or type or.
Yes, for not like Java where you have symbols, you actually type the word and or in Python. Any other questions? All right. Well, I'm done with you. I'll stick around and see if you want to do anything else.